Hello and welcome to this video for Chemistry 30 in the Electrochemistry unit. In this unit, we're going to learn how to balance half reactions and how to balance a net redox reaction. So you can be given questions where you're given what we call a skeleton equation or a skeleton reaction, where the balancing coefficients are left as blanks and you have to figure out what those balancing coefficients are. Now this is not quite as simple as what we did in Chem 20, where we're just balancing the number of atoms, because remember, a redox reaction involves a transfer of electrons and we need to balance those electrons. Okay, so it's not just balancing the atoms, it's also balancing the electron transfers. So we're going to start by looking at how to balance a half reaction. Okay, just like you see in the data booklet, you see some reactions where there's hydrogen ions and water, and where are those things coming from? That's what we're going to learn how to do. So the first step to balance a half reaction is to assign oxidation numbers, which my last video explained. Then you're going to balance the element that changes in oxidation number. You're going to then add electrons based on how many are being transferred. So for example, the number of electrons is always found by taking the change in oxidation number and multiplying by the number of atoms of that element that are going through that change. And then you have to also remember, if the oxidation number goes down, this is a reduction half reaction. It's an oxidizing agent gaining electrons going through reduction. When something gains electrons, that means electrons are a reactant. So they go on the reactant side. Like in the thermal unit, when you gain heat, it's a reactant. If the oxidation number of the element that is changing increases, it's acting as a reducing agent and it's losing electrons, undergoing oxidation. When something is lost, the electrons become a product. Okay? So the number of electrons are the change in oxidation number times the number of atoms of that element that is changing its oxidation number. And then whether they're a reactant or product depends if the oxidation number is going up or down. After we've added the electrons, we can then balance any oxygen atoms by adding water to whichever side is oxygen deficient. And then, as long as you're told this is happening in an acidic environment, which for Chem 30 it always is, you're then going to balance your hydrogen atoms by adding acidic hydrogen ions. Last, there's a check that we can do for ourselves, where the net charge of the reactants must equal the net charge of the products. So let's look at a couple of examples for doing this. So balance the following half reaction. So we have CrO4 2 negative becoming CrO2 negative 1. So if I start with oxidation numbers, oxygens we know are always -2 unless they're in hydrogen peroxide. There's 4 oxygens, so this adds up to -8. The net charge of this ion is -2, so I need a +6 from my chromium to add up to -2. On my product side, again, my oxygens are -2. I have 2 of them, that adds up to -4. The net charge of this ion is -1. So my chromium has to add up to +3. There's only 1 chromium, so it carries the entire +3. Okay? Again, if you're struggling with oxidation numbers, my last video looked at assigning oxidation numbers. So you can watch that if you need to. Now, what is happening? Oh, wait. What element is changing in oxidation number? The chromium. The chromium is changing from +6 to +3. So I need to make sure I have the same number of chromium atoms on each side. There's 1 chromium atom on my reactant side and 1 chromium atom on my product side. So they are balanced. You could, if you wanted to, put a 1. Just to remind yourself that, yes, I checked and made sure that my element chromium, the number of atoms of chromium, is the same on each side. Now I can look at my electrons. So my electrons, again, I can write this down here, are the change in oxidation number times the number of atoms that element is going through that change. So my change in oxidation number, I'm going from +6 to +3. So the change is by 3, and there's 1 chromium atom on each side. They should always be the same on each side, right, if we balance them properly. So that means I have a transfer of 3 electrons taking place in this reaction. And notice again how my oxidation number went down from +6 to +3. So that means my electrons are being gained. If they're being gained, that means this is a reduction half reaction, and my 3 electrons must be on the reactant side. Okay? Next, we add waters to balance the oxygens. I have 4 oxygens on my reactant side and only 2 on my product side. So I'm going to add 2 waters to give me an additional 2 oxygens on my product side, and that now gives me 4 oxygens to match the 4 on the reactant side. And then last, we add hydrogen ions to the side that needs more hydrogens. I have 4 hydrogen atoms on the product side from my 2 waters, so I need to add 4 hydrogen ions. Okay? Now, to check if I've done this reaction correctly, I'm going to erase this to have a little bit of space, and I'm going to show you this net charge balancing rule that we can use to check ourselves, okay? I'm just going to erase some of these numbers below so I have some space. Now, the way the rule works, the net charge of my reactants, all added together, must equal the net charge of all of my products added together, okay? Now, what do I mean by the charge? If I look here, I have 4 hydrogen ions. Each hydrogen is +1, so I have 4 plus from the 4 hydrogens. I then have 3 electrons. Each electron is -1, so I have -3, and I'm adding these together. And then my ion here, my polyatomic ion, has a net charge of 2 negative. So if I add all of those together, I have -5 and +4, so my net charge of my reactants is -1. My products, I have this CrO2 -1 ion. There's 1 of it, so it's -1. And water, any ionic or molecular compound, is just 0. So when I add those together, again, I get -1. The net charge can be anything. They just have to be the same on the reactant and product side. Okay? So that's a check to make sure that you balanced everything correctly. So 4 hydrogen ions and 3 electrons are reacting with CrO4 to produce CrO2 and 2 water molecules. Okay? That is how we balance a half reaction. This, again, is a reduction half reaction because the oxidation number went down of the chromium, so it gained 3 electrons. Let's look at another example. We have HClO2 becoming Cl2 gas. So if I assign my oxidation numbers, my oxygens again are -2. There's 2 of them, so that's going to add up to -4. This is a compound with no net charge, so oxidation numbers have to add up to 0. I know my hydrogen is +1, so I need a +3 from my chlorines. Okay? And then on my product side, chlorine is in its element form, so it is 0. So the element changing in oxidation number is chlorine. Notice how there's 2 chlorines on the product side and only 1 on the reactant side. So I need to put a balancing 2 in front of this compound to balance my element that's changing in oxidation number, the chlorines. I now have 2 chlorines on each side. Now to figure out my transfer of electrons, my oxidation number is changing. I'll put the formula first. Change in oxidation number times the number of atoms going through that change. So chlorine's oxidation number is changing by 3 from 3 to 0, but there's 2 atoms of chlorine going through these changes. So I actually have a transfer of 6 electrons. Now my oxidation number is again going down. So this is a gain of electrons again. This is a reduction half reaction. So my 6 electrons need to be a reactant. Okay, reduction reactions, electrons are being gained, they are a reactant. Now, waters. I have 4 oxygens on my reactant side, so I need to add 4 waters on my product side. I now have 8 hydrogens on my product side, but I already have 2 on my reactant side. So I just need another 6 on my reactant side. Okay? So now to do the check and make sure that we have proper balanced net charges on each side. I'll use purple again. I have 6 hydrogens, so they're going to contribute to 6 positive. I have 6 electrons, they're going to contribute to negative 6, and this is a compound with no net charge. So plus 6, negative 6, and 0 add up to 0. So the product side also needs to add up to 0. Chlorine is an atom, so it's 0. And I have another compound. Compounds are always 0. So those also add up to 0. So once you balance your reaction, if you check for net charge of reactants equals products, good chance you balance the reaction correctly. Okay? And that is how we balance half reactions. Now we're going to look at balancing a net reaction. Okay? And there's 2 methods that I'm going to show you for how to do this. The first method is the half reaction method, doing basically what we just did. Okay? But again, we're doing it to an overall reaction. So we have to first start by identifying the 2 half reactions that are reacting, balance each of them individually like we just learned, and then multiply them back together, making sure the electron transfers balance. Okay? This method is a little bit longer. So what we're going to do is separate this into 2 half reactions. So I have the compound, or the ion, CrO4 2- becoming CrO2 -1. And my other half reaction is going to be SO3 2- becoming SO4 2-. Okay? I'm going to balance these 2 half reactions the way we just learned and then put them back together. So we actually did this one, the first one, right here. Okay? This was the CrO4 becoming CrO2. We took 4 hydrogen ions and 3 electrons and 2 waters to be formed. So I'm just going to copy that down. You could, again, go through and do it again, but we already knew we had 3 electrons being transferred, and we had 4 hydrogen ions, and we had 2 waters. Okay? The second one I'm going to have to do because that one wasn't an example we did already. So we have -2, -6. This has to add up to -2. So I have +4 from my sulfurs to start. -2, -8. This has to add to -2, so I have +6. Okay? My electron, so my sulfur is the element changing in oxidation number. There's 1 sulfur on each side, so it balances. My change in oxidation number is 2 times 1 atom, so I am losing 2 electrons. Okay, I should always have 1/2 reaction as reduction, 1/2 reaction as oxidation, right? One's gaining electrons, one's losing electrons. Now I need a water on my reactant side because I was short one oxygen. And that's going to mean I need 2 hydrogens on the product side. I'm kind of running out of space here. Okay? Now, to balance these half reactions, I need the electrons to transfer. I have 3 electrons and 2 electrons. The first common thing I can get them to is 6. You always want to pick the lowest common multiple you can get them to, which is 6. So I need to multiply this half reaction by 2 and multiply this half reaction by 3. Okay? So this will become 8. This will become 6. This will become 2. This will become 2. This will become 4. This one will become 3, 3, 3, 6, and 6. Okay? Our electrons now cancel. But what else can cancel? Our hydrogens. I have 6 hydrogens on the product side and 8 hydrogens on the reactant side. So 6 can cancel with 6 of those 8, leaving us with 2 hydrogen ions. Our waters can do the same thing. I have 3 waters here. They can all cancel with 3 of the water products. They have to be on opposite sides to cancel, and that leaves us with 1 water molecule on the product side. So now my net reaction is 2 hydrogen ions and 2 CrO4, 2 minus, are reacting with 3 SO3, 2 minus, and I am producing 2 CrO2 minus 1 and 1 water molecule and 3 SO4, 2 minus. Okay, this again is the long way of balancing a reaction. Okay, splitting them into individual half reactions, balancing them separately, then essentially what you're doing, these coefficients are coming from telling you how to balance the electrons. Okay, so I have to multiply the chromium half reaction by 2 and the sulfur half reaction by 3. Now there's a shortcut method. I'm going to show you how to do this next. But this is the full complete half reaction method. The other method I'm going to show you is called the oxidation number method. And again, it starts by assigning oxidation numbers, but rather than going through and writing each half reaction, we're just going to use a line to join the elements changing an oxidation number to what they become. And on that line, I'm going to say how many electrons are being transferred. And then I can figure out what I need to multiply the reactions by to make those electron transfers balance. Okay? So for example, we start by ignoring the hydrogen and waters. They're just there again to balance the O's and the H's. So I'm going to start by assigning oxidation numbers to everything else. My oxygens add up to -8, and this net ion is going to add up to -1. So I need a +7 on my Mn. Sulfur, oh, we already kind of looked at this, but we'll do it again. It's going to start as +4. My MnO2 product, my Mn is going to add up to +4. And my sulfur is going to need to be +6 on the product side. Okay? So, rather than writing them all out and figuring out their half reactions, I'm going to draw a line from the Mn to the Mn. Okay? Now again, I need to make sure my MNs balance in the number of atoms of MNs on each side. I currently have 1 MN and 1 MN. Okay, so I can put little invisible ones there if I want to, or I can leave it blank. Sulfur, I'm going to do the same thing. My sulfur is 1 atom on this side and 1 atom on that side. So I'm going to leave those as ones to start. Do this in pencil, those numbers are going to change. Okay, so now I write down the number of electrons being transferred in each of those half reactions on their lines. My manganese is going from +7 to +4. So the oxidation number is changing by 3. And again, there's 1 atom of manganese going through that change. So I have 3 electrons being transferred in the manganese half reaction. The sulfur half reaction is going from +4 to +6. So its oxidation number is changing by 2. And again, there's 1 atom going through that change of sulfur. So that half reaction is transferring 2 electrons. Okay? So now, again, I need to visualize this. I have 1 half reaction transferring 3 and 1 half reaction transferring 2. The first common multiple I can get them to is 6. So I need to multiply the manganese half reaction by 2. So everything that goes to that line gets multiplied by 2. Okay? And the sulfur half reaction, I need to multiply by 3 so that I can get it to 6. So everything that goes to the sulfur line gets a multiplied or a balancing coefficient of 3. Okay? Now my half reactions are balanced based on electron transfers. Now I just have to look at my oxygens and hydrogens. Okay? On my left-hand side, I have 8 plus 9. I have 17 oxygens on my reactant side. And on my product side, ignore the water to start, I have 4 plus 12 is 16. So I need 1 more oxygen, which means I need 1 water molecule. Then my hydrogens, again, start by ignoring that hydrogen. On the product side, we have 2 hydrogens. And on the reactant side, to start, we have none. So I need to add 2 hydrogen ions. So I put a 2 in front of the hydrogen ion. And now my reaction is balanced. 2, 2, 3. 2, 3, 1 are my balancing coefficients, okay? So this is the second method called the oxidation number method. That's a little quicker and easier. On a quiz, you can choose which method you want to use to balance a redox reaction, okay? I prefer this method. It's a little quicker and takes up less space. Let's do another example using this method just to make sure we're good. So in my next example, again, I'm going to start by omitting the water and the hydrogen. I'm going to assign oxidation numbers, -8 from the oxygens. This compound adds up to 0, so I need +8. There's 2 nitrogens here, so each nitrogen would be +4. Here I have a simple ion bromide, so it is just its ion charge. Here I have NO2 -1, so this adds to -1, so the nitrogen here is +3. And over here I have -6 for my oxygens. This adds up to -1, so I have a +5. Okay? My bromines, I have 1 bromine and 1 bromine, so those look good. But my nitrogens, I have 2 nitrogens and only 1 nitrogen. So I need to put a 2 in front of that compound to get 2 nitrogens on each side. And then I can put a 1 there. Okay? Those again are the temporary balancing coefficients. They're going to change once we figure out how to balance the electron transfers. Okay? So my nitrogen. my number of electrons being transferred by the nitrogens. The change in oxidation number is from +4 to +3. So the oxidation number is changing by 1, but there are 2 atoms. Remember, transfer of electrons is change in oxidation number times number of atoms. There are 2 nitrogen atoms on each side. They need to be the same on each side. Okay? So that means there's actually 2 electrons being transferred in the nitrogen half reaction. The bromine, be careful, it's going from -1 to +5. That is a change of 6 in oxidation number. There's only 1 bromine on each side, so that's a transfer of 6 electrons. Now the first common thing I can get both of these to, I'm going to use blue this time, is 6. So I multiply this half reaction by 3. So 2 times 3, that'll become 6. 1 times 3, that'll become 3. And then my bromine half reaction is just 1s. So the 1 stays a 1, the other one stays a 1. Okay? And now I can balance my hydrogens and oxygens. So oxygens first. Omitting, I don't know why I crossed out the water. We're going to start with those crossed out. I have 12 oxygens on my reactant side, and 12 plus 3, 15 on my product side. So I need 3 water molecules. And then my hydrogens, that gives me 6 hydrogens. And on this side I have none, so I need to add 6 hydrogen ions. So my balancing coefficients are 3, 3, 1, 6, 1, 6. Okay? Now I do have a sample diploma question. So again, we're doing the same thing. You can pause this video, give this a try. I'm starting again by assigning oxidation numbers. I'm ignoring the hydrogen and the water. Okay, my zinc, I have 1 zinc on each side. But my nitrogens, I have 2. So I need to put a 2 in front of that nitrogen and a 1 there to start. And now we use our lines to look at electron transfers. So my zinc change in oxidation number is 2, and there's 1 zinc atom on each side. So that half reaction is transferring 2 electrons. My nitrogen, the number of electrons being transferred, the change in oxidation number is 4, but there's 2 nitrogen atoms on each side. So we are actually transferring 8 electrons there. So I have 2 and 8. The first common thing I can get them to is 8. So I need to multiply the zinc half reaction by 4. So that becomes 4, and that becomes 4. The nitrogen reaction is just multiplied by 1. So I can leave this as 1 and leave this as 2. Then we look at our oxygens. I have 6 oxygens on the reactant side and 1 on the product side. So I need 5 waters. And then my hydrogens, I have 10 hydrogens on the product side and none on the reactant side. So I need 10 hydrogen ions. Okay? So our balancing coefficients are 10, 4, 2, 4, 1, 5. Now the answer is looking for the balancing coefficient in front of zinc, that was a 4. In front of water, that was a 5. In front of N2O was a 1. And in front of NO3 was a 2. Okay? And that is how we balance half reactions. Thank you for watching this video.